We're going to look at the quotient rule. So, the quotient rule is basically the product rule, but you have to divide it by v squared, and there's a subtraction in between and stuff. So you can see it on the top there. Now, I personally don't use the quotient rule. You can choose not to use it, and I'll show you how you can do it without it. But the quotient rule does make it a little bit simpler. If you're worried about remembering all of these rules, don't worry, it is actually on your formula sheet at the exam. So depending on your teacher, they'll usually provide it for you, or you can write it in your book, whatever. So your choice on how you want to do it. So find the derivative of y equals a sine to t over t squared with respect to t. Now, the quotient rule only works if you write it so that the top one is u, according to the rule there anyway, and this is respect to t, and the bottom one being v. So then let's follow it. So dy dx is equal to v, which is t squared, times du dx. So that's 2 cos 2t, minus u, which is sine 2t, times dv dx, which is 2t, or in this case, dv dt. Same with the other one. Speaking of which, I should change that. And we have v squared, so that's t squared squared. So then we get 2t squared cos 2t minus 2t sine 2t all over t to the power 4. We can simplify that by dividing all of the top ones by 1t. So left over t cubed on the bottom. So that's 2t cos 3t minus 2 sine 3t. Now, I'll show you with the same example on how to do it without a quotient rule. This is just in case we do forget, I suppose. That way, you know how both ways work. If you're not using the quotient rule, we're going to use the identity that x to the power -1 gives us 1 over x. So then y is equal to sine of 2t times t to the power -2. And then you just use the product rule. So then dy dt is the derivative of the first one, so 2 cos 2t times the second one, plus the derivative of the second one, -2t to the power, -2 times t to the power of -3 times sine of 2t. So then we get 2 cos 2t over t squared minus 2 sine 2t over t cubed. Then if you wanted to put it together, on the cos one we need to times both of them by t, so the bottom's the same. So then we get 2t cos 2t minus 2 sine 2t over t cubed. So you can see it's the same. The only thing is you have to double check that you've done the negative power. If you haven't done the negative power, it's hard to make it work because you will stuff it up. Find the derivative of f of x equals to cos 3x all over 2ex minus x, and hence find the gradient at the point where x is equal to 0. So, u of x equals to cos 3x, v of x is equal to 2ex minus x, u dash of x, so the derivative is -3 sine 3x, and then b dash of x is 2ex minus 1. So then, putting all of this together, dy dx is equal to v 2ex minus x times du dx, negative 3 sine 3x, minus u, so cos 3x, times dv dx, which is 2ex minus 1, all over v squared. At this point, I would suggest you not expand it, because it says we need to find the gradient at a point. It doesn't say anything about simplifying it, but it's easier if we don't expand it. You'll see why in a second. So subbing x equals 0. So we've got 2 times e to the power 0 minus 0, so that's 0. And then we have negative 3 times sine of 0, which is 0. Cos of 0, which is 1, times 2 e to the power 0 minus 1, and then 2 e to the power 0 minus 0. Remember, e to the power 0 is a 1, so the first little section actually gives us a 0, because we have 1 times 0 minus 1 times, we have 2 minus 1, which is 1, all over 2 times 1, and then squared, so that's a 4, so negative 1 over 4. If we actually tried to expand and simplify it, instead of multiplying these zeros, we would have to manually work out each and every single term, which isn't as nice.